Okay, so you've definitely seen the results. I mean, they're all over your feeds, right? It feels like almost overnight, AI just started creating these things that, well, they feel less like something a computer did and more like actual magic.
You've got models like Sora that can take a simple sentence and spit out this breathtaking, high-def video that looks completely real. It's wild. It somehow understands physics and light and movement in a way that is just astounding.
And then you look at the life sciences, and AI is tackling problems that have stumped scientists for decades. Things like predicting how a protein will fold, or even designing totally new drug molecules from scratch to fight diseases. It's incredible.
And it's not just stuff happening on a screen. This same core idea is giving physical robots the ability to learn and do really complex chores. We're getting that one step closer to the kind of helpful robots we've all been imagining since we were kids.
Now, all of these things feel totally different, right? Insanely complex problems from different fields. But what if I told you that a single, surprisingly simple idea is the engine driving all of them? Seriously, so let's break down exactly how it works.
The whole concept is called diffusion. And really, at its heart, it's like a two-step dance between pure chaos and perfect creation. It all starts with a weird idea. You first have to learn how to destroy something perfectly so that you can then learn how to create it from literally nothing.
Okay, so here's how it works. First, you take a clean piece of data, let's say an image, and you just systematically destroy it. You add a little random noise, then a little more, step by step, until it's just complete unrecognizable static. Now that part's actually pretty easy. The real magic, the genius of it all, happens in reverse. That's where you train an AI model to be the world's best denoiser. You teach it to perfectly undo every single one of those noisy steps to get right back to the original image. And look at how methodical this is. The image doesn't just explode into chaos all at once. It slowly, and in very controlled steps, dissolves. And because the AI knows exactly how that noise was added, it can learn the precise rules to just run that whole process backwards, to rebuild a crystal clear image from what was pure static.
So, there you have it. That's our core definition. A diffusion model is basically a machine that has become an absolute expert at reversing noise. And once it's an expert at that, well, you can give it any random noise, and it can shape that chaos into a brand new, coherent piece of data. Doesn't matter if it's an image, a protein structure, or the plan for a robot's next move.
Now, for years, that old step-by-step denoising thing was super expensive and complicated for computers to do. But then, a massive breakthrough happened that made the whole idea so much more elegant and efficient. It simplified the whole path from chaos to creation.
You see, the early models had to painstakingly retrace every single little step on that long, winding road from noise all the way back to the clean image. But this new idea, called flow matching, asked a really brilliant question. Why take the scenic route? Why not just teach the model the most direct, straight-line path from any noisy point right to the final clean data?
And this quote just nails the core insight. Forget all those little steps in between. Instead of teaching the model to take tiny baby steps backward, you teach it to understand the overall direction, the global velocity, from chaos straight to order. It doesn't matter where a noisy pixel is, the model learns to point it directly where it's supposed to be in the final image. It's such a simple and profoundly powerful shift in thinking.
And when we say simple, we really mean it. This isn't some crazy 1,000-page equation. The fundamental logic, the training loop behind one of the most powerful AI techniques out there today, can pretty much be written down in just a few lines.
I mean, look at this. This is basically it. Step 1, you just create a noisy image by mixing the real data and some random noise. Step 2, you calculate the velocity, which is just that straight line path between them. Then in steps 3 and 4, you show that messy image to your AI and you ask it, hey, predict that velocity. The model gets better simply by trying to close the gap between its guess and the real answer. That's it. That's the entire learning loop.
So, because this core logic is so simple and so universal, I mean, it's just data and noise, you can apply it to almost anything. And that has led to an absolute explosion of uses, way beyond just making cool AI art.
As one researcher put it, diffusion has pretty much eaten all of AI. Seriously, from generating media to life sciences to robotics, this is now the go-to technique. The source we're looking at says that right now, the only two big areas where it isn't completely dominant are the kind of text generation you see in chatbots and those super complex game-playing AIs. For now, anyway.
And the list of what it can do is just staggering. We're talking Nobel Prize-winning work on protein folding, the most accurate weather forecasting systems we've ever had, new ways for robots to learn complex tasks, discovering new drugs, and yeah, generating not just images, but video, computer code, and even text.
Okay, so this is obviously way more than just a clever algorithm. The way diffusion models work, it tells us something really fundamental about a new way to build intelligence. And that has some huge implications for all of us.
You know, if you kind of squint at it, diffusion models seem to work a little bit more like we do. First, they actually use randomness. They embrace it, just like biology and nature do. They see chaos not as a problem to be solved, but as the starting point for creation. And second, they think holistically. Instead of generating one word or one pixel at a time in a line, they generate whole concepts at once, refining the entire picture together. And that feels a lot closer to how we think and create, doesn't it?
So what's the big takeaway here? The advice for anyone building in this space is to see where this is all heading. As the saying goes, skate to where the puck is going to go. The progress here is just undeniable, and it's getting faster. These methods are going to keep getting better, and they're going to solve more and more problems.
Just think about this for a second. The quality of AI image generation has gotten something like 1,000 times better in just the last 5 years. 1,000 times. Now, just imagine that same rate of progress being applied to robotics, to medicine, to discovering new materials. We are at the absolute beginning of watching this revolution unfold.
So an idea this simple, learning how to create something by first learning how to perfectly destroy it, is already turning entire industries on their heads. It really just leaves us with this one thrilling question. As this technique gets even better and spreads to even more fields, what on earth will it generate next?